presenting Mike Learning Out Loud. So today we are going to learn about the Indian origin scientists who reshaped the AI world as we know of it and about the transformer model. Today we have Mr. Deepak with us. Hi Deepak.
Hello, Shivani.
So Deepak, whenever I am in curiosity and have any doubts about anything related to AI and technology, I run to you for your expertise and guidance. So today I want to learn about transformers and the technology behind it because honestly it's very confusing since I'm from a non-technical background. So I would need your help to guide me through it.
Okay, Shivani, I think you're really diving deep into AI because I know the transformer architecture you are talking about, and it's pretty technical things and I would say even very complex, but it's in a back of current generative AI and LLM models. Any particular reasons you are going that deep, I would say?
So while exploring the area, I came across a few articles where I got to know about Mr. Ashish Vaswani, who was an Indian origin scientist, and that piqued my curiosity on what is the subject that he's talking about and how is it transformative and how it has changed the landscape of entire artificial intelligence. So I would need your help to decode the article since it's too complex for my non-technical brain to understand as of now.
Perfect, Shivani. This is Ashish Vaswani you are talking about. Ashish Vaswani was main author of one research paper which got published in 2017, and it was titled "Attention is All You Need." And I know he was a part of a Google team out there, and I think 6, 7 brilliant minds worked together on that research. And obviously, Ashish Vaswani was in the center of it. That's why his name keep popping up a lot out there. And attention is all you need turn out to be a part of a transformer architecture for LLM and GenAI, and it solved a big problem, I would say, which earlier AI model were having. And yeah, obviously it was a quite breakthrough research and invention, I can say. So if you really want to understand transformer architecture, as I said, it's very technical, it's very complex. Although I will try to make it very simple, and I will explain in a layman language so that you can and everyone can absorb it. Before I jump into a transformer architecture, so I will say like AI became popular after people started using Gen AI, and but AI was always there. So let's see what the Gen AI is and relationship between the AI out there. With the mother of Gen AI. So if I say mother of Gen AI is machine learning, ML. Gen AI is a subset of ML eventually. So I will rather go and try to explain what the machine learning is, and we will start from there. Okay, so that let's make the basic clear. Machine learning is basically where you say that where the machine learns from the data and where we apply a lot of mathematical equations, formula, algorithm, and to onto that a huge amount of a data, and it's is always the quantitative data, is a metrics, numbers, and some sort of things, and we find the patterns, and we are able to make predictions and all. So that was always was happening. As this Gen AI came into picture, and that's used the similar logic, because Gen AI, it is rather than predict, it is predicting. So because when you are typing something, what is it is predicting what should be the next word. Challenge with the language uh, is not a numeric and number. There is no 2 plus 2 is equal to 4. So it's very difficult to apply that mathematical logics and formula onto the language. So if you say love plus hate minus crying, does it make sense?
It does not make any sense.
Yeah, right. Yeah, because yeah, you can't apply math on the
Correct.
language, and so that was the biggest problems was there. So there was a trick was used that every word, and most of this Gen AI model, they have a big huge vocabulary, and they convert this word into a some sort of a quantitative data. It's not a normal number, it's rather the matrix of numbers out there. If I give you an example, uh, if you are walking on that street alone, and someone basically tried to rob you, scare you out, snatch away your mobiles, your stuff, but you are safe. You escape from the situation. What next things you are going to do?
I would go to the nearest police station and file a report against the thief.
Perfect. And when you go to police station, they will ask who that man was. And then you will explain that because you don't know that individual. So you will explain in terms of that you will say probably his age was 40 years and his hairs were gray, or probably he was 6 feet tall or something like that. So you will use a lot of features and you will turn an identity into a data. Okay, so that is the data points you have given. Okay, and they will use this data point to identify this individual and track it down or whatsoever. Okay, so that's the same way the words are given some data based on to a number of dimensions and features. So if I talk about, I think OpenAI, they use 12,000 plus dimensions on the words. Okay, and so how it helps actually? It helps because now you have a numbers allocated out there. You are able to see that how these things, one word is related to other. What is that level of closeness is there? Okay, so you can identify some sort of a relationship and how far and close these words are and or how they're related. So these are that helps that you can do some sort of a calculation over it. Then you can do some sort of a prediction. Okay, uh, now, but there's language has another challenge out there. If I take in a word, it can have a different meaning. Same word can have a different meaning when the context is different. Okay, and if I give you an example, uh, if I say I did dishes, they were fill in the blanks. So what would be the word?
Dirty,
Dirty, obviously. And I say I made dishes, they were
delicious.
delicious. Okay, although it's the same things out there, but we are using dishes in both the sentence, but the meaning of dishes is changing on that based on the context out there. And that's why your predicted word is changing as well. So uh, that's the challenge I think earlier LLM model were having. And that's why this attention is all you need concept came into picture. Now, what this concept says about that every word in the sentence is is going to give an attention to the predicted words out there. Okay, and based on to their weightage and importance, they are applying some sort of scoring on the predicted word. So it's not like a single word or some things like a last word is doing a prediction. It's rather every words previously is applying some sort of scoring out there, and that's what that is saying the predicted word needs an attention. Okay, and what is the highest scoring comes to the word, I think that is the most probable word, and that's why that is a selected one. So that solved that problems of context, different context into the language. So that was the one part of it. But if you really see language has any language has another challenge, because language context is the one challenge. Another challenge is the perception.
Correct.
If I've written a paragraph and I ask five people to read that paragraph, they may make a different meaning out of that. Their interpretation may be different. Okay, because they have a different perception. So again, this challenge come about the perception now, that how to solve that perception challenge. Okay, so perception challenge, obviously you will have to consider multiple perceptions and then you will have to consolidate it. So if I give you an example, there is a chairperson in an organization, and he has some problem statement. He has some experts in his team. He calls that five or six expert inside the room and gives that problem statement to them and ask them to give their view and opinion or solution whatsoever. And everyone gives some sort of opinion on it, and they have a different opinion because they have a different perception. And then eventually that chairperson takes all that inputs and he can process it out, and he basically consolidate and create one output from there. Okay, now exactly the same things is happening here. So here every expert is in a different head. So there the multiple heads are working. So the same way that multi-head concept got applied into this AI models out there. And this multi-head concept is where that rather than the one system and one process is processing that information, there's a millions or maybe thousands of neural networks works together to process the same information. Okay, and these neural networks are working in parallel, and then they basically they generate an outcome, and then there is a somewhere what we call is a transformer. Is everything is now is a transformer, which basically does that level of some layering and consolidation, and producing in a one outcome to the users. Okay, so there was this comes about a transformer architecture. So the transformer architecture is like a chairperson. Neural networks are the different heads. So there's a multiple heads, and every head is processing, and they're using a concept. Attention is all you need. So okay, so that sequence of the problems are solved within that. It does have a many other things. So like if I give you an example in language, another challenge is positioning of the word as well. So where it comes the concept called position embedding, which ensure that when that either you are generating some outcome, so you have to position word correctly, or probably when you are reading some sort of content, you have to understand what is the positioning of the word is and how does it create a difference meaning out there. So that all about is a transformer architecture in nutshell in a non-technical language, if I say. So does it answer your question, clarify your doubt?
Absolutely. You simplified the entire complex problem into very palatable examples, and it's very easy to understand now. And thank you so much for the concept clarity. So, since we are here, I would like to go back to the start of my session and would like to give a shout out to Mr. Ashish Vaswani. He is the backbone of how we know AI right now. So Mr. Ashish Vaswani did his graduation from India and then proceeded to do his further education from California. And he co-authored paper, Attention is All You Need, which transformed the AI world by introducing the transformer model. Transformer model was instrumental in development of several state-of-the-art AI models that we know, for example, GPT-2, GPT-3, and BERT. So, thank you all for staying together in this session and learning out loud with us. Thank you so much, Deepak, for highlighting the complex topic with such ease and grace. Thank you so much.
Thanks,
Let's
Shivani. Perfect.
so
Yeah.
thank you all for staying this curious soul and stay tuned for more such episodes. Keep liking, sharing, and subscribe to our channel, Menti Mike Learning Out Loud. Signing off for today. Bye.
Bye.